Hey everyone, welcome back. Today we're going to explore non-blocking I/O and async patterns, the technique that makes modern servers, chat apps, and multiplayer games fast and scalable. If you've ever wondered how a server can handle thousands of users at the same time without slowing down, you're about to find out. Let's start with the basics. In blocking I/O, imagine a chef puts a pizza in the oven and just waits until the task is done. They can prep another pizza, chop veggies, or start any other dish until that pizza is ready. This works fine for a few orders, but what if hundreds or even thousands of customers arrive at the same time? You'd need hundreds of chefs, which is expensive and inefficient. Now, in non-blocking I/O, the chef puts the pizza in the oven and immediately starts working on the next order. When the pizza is ready, they are notified and serve it. In programming, this means the program doesn't sit idle waiting for files, databases, or network responses. It keeps running and reacts when results are ready. That's how a single server can handle many tasks efficiently. In systems like Node.js, this is managed by the event loop. The event loop continuously checks for tasks that are ready to run. When a task finishes, it triggers a callback or event handler. Think of it like a manager at a busy desk. They consistently check what's ready to process and send it to the right worker immediately. This allows a single thread pool to handle thousands of tasks without blocking. Next, let's look at how programs manage non-blocking tasks. There are three main patterns. First, callbacks. These are functions you pass to run when a task finishes. They're simple but can get messy if you nest too many of them. It's like leaving sticky notes for the chef that say, "Call me when the pizza is ready." Works for a few orders, but messy for hundreds. Second, promises. These are objects representing a result that will come in the future, letting you chain multiple tasks cleanly. Think of it like a ticket system. Each pizza order gets a numbered ticket. The chef checks tickets in order and serves pizzas as they are ready. Cleaner than sticky notes. Third, async await. This is modern syntax over promises. It looks synchronous, but it's still non-blocking. Imagine an assistant watches the tickets and notifies the chef exactly when the pizzas are ready. It looks like the chef is waiting, but they're still busy preparing other dishes. Key takeaway is that all three patterns help programs stay responsive while waiting for tasks, and the difference is mainly how clean and readable your code is. Now let's go a bit deeper. Two important concepts are the reactor pool and the thread pools. The reactor pool acts as the server's event manager. It waits for events like incoming messages or new connections, and when an event happens, it dispatches a handler to process it. Next, thread pools. Some tasks are heavy and could block the server, like database queries or complex calculations. A thread pool is a set of worker threads that handle heavy tasks in the background. When the task finishes, the event loop picks it up and continues. Reactor pool is like a receptionist at a busy restaurant. She doesn't cook herself but sends orders to the right chef. She just manages the flow. In thread pool, the chef has an assistant chef for heavy dishes. The chef pool keeps handling new orders while assistant cooks. When a dish is ready, it's served. Together, the event loop, async patterns, and thread pools let servers handle thousands of tasks efficiently. At a lower level, the operating system helps the event loop know which tasks are ready. Linux provides tools like epoll, select, or poll, which lets the loop efficiently check which sockets or file can run next. You don't need to implement these yourself, just know that they're the foundation behind high-performing non-blocking I/O. Let's see this in action with a chat server handling thousands of users. Every user's messages are processed asynchronously without a separate thread per user. The event loop dispatches these messages to the right handlers. Heavy operations like saving in the chat are handled by a thread pool in the background. The result? A single server can manage thousands of simultaneous conversations smoothly. To summarize, non-blocking I/O is a program that continues running while waiting for tasks. Async patterns are callbacks or promises or async await, and these are the ways to manage tasks. Reactor patterns or event loops are the backbone for dispatching tasks. Thread pools handle heavy tasks without slowing the main thread. ePoll or select is the OS-level monitoring for efficiency. Combining all these three, you can scale applications to thousands or even millions of concurrent users. In the next video, we'll explore event-driven architecture and message brokers, which often work hand-in-hand with non-blocking I/O to make huge systems work efficiently. Thank you for watching, and I'll see you in the next one.